Okay, so what we're gonna do today is we're gonna talk about mean value theorem, and this is a video you can watch at home. But this is like actually like a very important theorem, and this is so important that where most of the student, most of AP exam, you're gonna for sure see this, and even as much as like even competition question, they usually have this, and it's very doable for most of the kids. So it's very important one. So I want a student to get very good at this theorem. Um, so here's the theorem goes. The mean value theorem is basically start with rules. The rules value theorem is a stepstone. So let's introduce the rules again. And we talked about this O means f prime of x equal to 0. So rule theorem, basically there is a 3 condition. And the first condition is f of a, no, sorry, f of x is continuous between a and b. And the second condition is f of x is differentiable between a and b. And third thing says f of a equal to f of b. So you have to have those 3 conditions, and there is at least one c where f prime of c is equal to 0. So that's Rolle's theorem. So Rolle's theorem is by a mathematician named Michael Rolles. And Michael Rolle hated calculus, but later on in his life, he kind of changed his mind about calculus. He says, well, calculus kind of makes sense now. I agree with calculus. So another mathematician come in play. So the second mathematician, his name is called Lagrange. I don't know how to spell it, but I'll find it for you. Lagrange, Joseph Louis Lagrange. That's the mathematicians. So Joseph, they're not gonna test the name. Don't worry. Lagrange. I'm just giving it to you so you can put the name on the face. Joseph Lagrange, 1736 and 1813. So rules at 1691. So this is 1691. He's born in 1691. So this is a much later. It's at about 1700. So probably I would say probably 1750s. So that's gonna be Joseph Lagrange. Lagrange says after 60 year. So he kind of look at this theorem. He says, well, I want to modify this theorem. And this modify this theorem is he actually just kind of stole the theorem and just kind of says, well, what if I create a theorem that with missing one of the conditions, right? Missing one of the condition. So which condition to miss? Well, we're still gonna say, sorry, we're gonna say this is mean value theorem. Mean value theorem. And we still says f of x must be continuous between a and b. And the second theorem says f of x is differentiable between a and b, not including endpoint. And then we just don't need the f of a equal to f of b. So this is the conditions. And the result is this. Well, what is the result? That's a very good question. So he kind of stole this. Why did I say he stole it? Because this is rules. Rule says, well, he kind of modify, I would say, still. So this is A and this is B. So this is a 2 point, it's going to be like this. Well, if you see the slope of those 2 lines, it's going to be 0. Therefore, whatever graph in the middle, it must have some part that's equal to 0. Does that make sense? Okay. So if it's a differentiable, then it's going to have this. Then you have a 1 0 here, or it could have 2 zeros here, and that's that. So the result is this. So he kind of tilt his head a little bit on the rules theorem. So let's just tilt to tilt the paper just tiny bit on the rules theorem, and we said, hey, that A and B doesn't have to be the same height, right? So let's just say, let's change the theorem again. Let's just get rid of this condition 3, and I'm gonna draw it again. I'm gonna say, hey, if you have those 2 points here and they are different height, well, different height can create a slope, right? This is a maybe b comma f of b, and this is a comma f of a, and then can I say it's f of b minus f of a over b minus a. Now, if they are continuous differentiable, guess what? You're gonna have a slope that's equal to the slope. So what I mean by that is this. I might have a function like look like a green one, a simple fraction look like this. And in this case, there is a slope at this particular point around ref right here, probably have the tangent line same as this slope. Those are the same. Just like the slope is equal to 0, except now slope is no longer 0 because the line of secant is kind of have a slope now. Can they have more than one? Absolutely. Can they have 2? Can they have 3? Yes. They can have as many as possible. Okay, so in this case, I can have more than one C. So if you look at here, there was probably a slope right here. And there's probably a slope right here. And there's probably a slope right here. They all same as this slope of the black line. They all have the same slope. So at this case, there is at least one C. So it's equal to f prime of C. Now, you actually done this on prior homework when we talk about the average rate of change is equal instantaneous rate of change. And that was the same process you're doing that. So you've done this before. It's not the first time you did this. It's actually this. So you can find a C. Now C has to be, there's at least one C, at least one C, where it has this result, but not including endpoint. So not including endpoint. Make sure, because that's parenthesis A, B, not including endpoint. Again, because the endpoint is not differentiable, so you should not including the point. So once you got a C is equal to 1 at endpoint, you need to get rid of them because that's not part of the answer. Okay, so that's mean value theorem for you. Now I'm going to show you on Desmos. Sorry, I'm going to go back to Desmos. And the way to look at how to work with Desmos is actually pretty cool. You're just going to Google this. And you're going to say mean value theorem Desmo, because there's probably somebody already make it. And this mean value theorem here. A nice thing about this is you see that we're going to give you a very simple graph. I don't know what the equation goes. So we're going to say the equation is maybe minus x, something like that. And we're going to say between we're going to say between -5, -3, -3 to -3 to 3. Okay, so let me -3 to 3. So you see that red line, right? And I'm going to change that maybe something like maybe to 100, -15 to 100. So the graph's going to be like that. Now you see the red line, right? You see the red line. If you see here, that there is one point where they have almost the same slope. They they almost have same slope. Let me change the function. Maybe x squared minus x is better. So like this. Okay, x squared minus x. So there must be one point where you see this red line. Do you see that there's the green line? We have the same slope of the secant line. The tangent is equal to secant. So that's why I told students when you talk about mean value theorem, think about when the instantaneous rate of change is equal to average rate of change, or think about secant slope is equal to tangent slope. And that's the best equal to. So they can have one places here. Now if I do it x4, let's say x4 minus x, so x4 minus maybe like a 16x, 16x squared, like this, or we have a w functions. So in this case, yeah, so you're gonna have a how many times is gonna have equal to them. Let me pick it up maybe, let's say it's from -2 to 3. So -2 to 3. So how many times does c value here? I mean, maybe -3 to 5, maybe. So maybe that change this from to maybe 500. Okay. And maybe something like this. Okay. How many times does that slope is equal to c here? And let's change this to x value maybe is from -5 to 5. -7 to 7, sorry. -7 to 7. How many times the slope is equal to this blue line? So let's look at it, right? Let's go back here. How many times? So probably right here. Probably right here, there's once. Right? And then there's probably twice. Do you see that green line? Right? It happened here too, but it just maybe the thing is not changing, so it's gonna be happen once. I don't know about here. And it's gonna happen again here. Twice. And then it's gonna happen again 3 times here. So I have same slope. So it can happen 3 times here. So even the idea for you to understand this is very, very important. Okay. So, and that'll be all. Now the finding a C just a arithmetic we done before.